Scattered across Europe are ancient forts turned to solid glass. These vitrified forts present one of archaeology's most stubborn mysteries. By the end of this exploration, you will see the distant past not as a primitive time, but as an age of startling and sophisticated experimentation. How could Iron Age societies generate heat so intense it melted stone? And was this terrifying transformation a catastrophic accident or a deliberate act of engineering? What does this glass fused into ancient ramparts tell us about the ambitions and fears of people who lived 2,500 years ago? How much of a civilization's true capability is lost between the lines of history? The transformation is visible even to the untrained eye. Where you would expect to see rough, stacked stones, you instead find a bizarre, almost volcanic crust. This is the signature of a vitrified fort. They are ancient hilltop strongholds built across Europe roughly 2,500 years ago, where sections of the defensive walls did not simply crumble with time. They melted. The stone itself was subjected to such intense heat that it underwent a fundamental change, fusing into a hard, glassy substance that binds the rubble together. This process is called vitrification. To achieve it, the stone, often granite, must be heated beyond 1,100 degrees Celsius. That is a temperature comparable to a commercial glass furnace or a volcanic lava flow. The result is not a smooth, polished glaze. It is a chaotic, bubbled, and often blackened mass, like a slag from a foundry, permanently welding the fort's ramparts into a single, monstrous piece. For centuries, since these structures were first formally described in the 1700s, that site has posed a single, relentless question. How, and more importantly why, would anyone in the Iron Age do this to their own fortress? The evidence for this incredible heat is not confined to a single, obscure location. To understand its scale, we must travel to the windswept coasts and rugged highlands of Scotland, where the mystery is written directly into the landscape. One of the most telling sights is the Broch of Clickamin on the Shetland Isles. Here, a massive stone tower known as a broch stands near the shore. While the broch itself is not vitrified, the defensive walls that once surrounded it show clear signs of that glassy fusion. This tells us the phenomenon was not an isolated fluke, but a recurring feature of fortifications from this era. For more dramatic examples, we look to mainland Scotland. At Tap O' Noth in Aberdeenshire, the hill fort's walls are not just melted in places, they are fundamentally transformed. The core of the rampart is a solid, dark mass of vitrified stone, visibly different from the ordinary rubble around it. Similarly, at Craig Fadrig, overlooking the city of Inverness, the fort's defenses bear the same strange, scorched signature. These sites, often perched on imposing hills chosen for their clear views and defensive advantage, share a crucial architectural clue. They were built using a method known as timber lacing. This was not simply a stack of stones. Builders would construct a stone shell, and within its core, they would carefully lay a latticework of sturdy wooden beams. This timber framework acted like internal scaffolding, providing stability and flexibility to the wall, allowing it to withstand shifts and impacts far better than a simple pile of rocks. It was a sophisticated technique, a mark of advanced Iron Age engineering, and it is this very wood, embedded deep within the stone, that lies at the heart of the leading theory. The idea is as simple as it is terrifying. If such a fort were set ablaze, whether by attackers or by some internal catastrophe, that internal timber lattice would become a furnace. Trapped within the stone, the burning wood would not just char, it would create a sustained, intense heat, potentially hot enough to melt the surrounding rock from the inside out. The stone itself would become the fuel for its own transformation. So, were these vitrified forts simply the tragic results of successful sieges, their brilliant defensive design turned against them in a final, fiery collapse? The timber lacing theory is compelling, but as we will soon see, the story is far from that straightforward. But the story of these glass forts does not end at the Scottish coast. To find its true scale, we must follow the mystery across the water to the continent of Europe. In the region of Brittany, in northwestern France, sits the fort of Pyrotechnic. Here, the evidence is not just a few melted patches. The entire defensive wall is a single, continuous, and almost monstrous mass of fused stone. It is a spectacular and undeniable example of vitrification on a grand scale. Far to the south, in the sun-drenched hills of Provence, the site of St. Blaise tells a similar, though more subtle, story. Archaeologists have found clear evidence of intense, localized heating that transformed the stone, leaving behind the same telltale signatures of glassy slag. These continental discoveries shatter any notion that this was a purely local Scottish curiosity. They force us to widen our view. The presence of these forts in different regions, built on different types of local stone, is a crucial piece of the puzzle. If the vitrification were simply a natural geological process, we would expect to see it only in areas with very specific, volatile rock types, but that is not the case. The stones at Pyrotechnic and St. Blaise are not the same as those in the Scottish Highlands. This variation strongly implies that the cause was not the rock itself, but something applied to the rock. The common denominator is not geology, but human activity. By comparing these scattered sites, a faint pattern begins to emerge from the ashes. It suggests that, for a time, across a wide swath of Iron Age Europe, certain communities possessed and employed a terrifying knowledge. They understood how to generate and perhaps how to control heat of an almost industrial intensity. This was not a universal practice. It appears to have been rare and specialized. But its occurrence in distinct cultural zones points to something more than accidental fire. It hints at a deliberate, though now lost, application of high-heat technology. Was this a weapon of war, a method to make a fortress's walls impregnable by literally welding them together? Or could it have served a deeper, ceremonial purpose, a ritual of transformation meant to spiritually fortify a community's home? The scattered, glass-clad ruins from Scotland to Provence stand as silent, stubborn monuments to that unanswered question. This conventional explanation offers a clear and logical chain of events. At its core is the timber-laced Rampart, a brilliant piece of ancient engineering. Builders did not simply pile rocks high. They constructed two parallel stone faces, creating a hollow core. Inside this space, they built a complex wooden skeleton, a lattice of beams and posts that locked the entire structure together. Think of it like the steel rebar inside modern concrete. It gave the wall flexibility and immense strength, allowing it to withstand the impact of siege weapons and the shifting of the earth itself. This technique has been confirmed at many vitrified sites through the discovery of post holes, the distinctive patterns left in the soil where massive wooden supports once stood, and through fragments of charcoal found fused within the glassy stone. The theory then follows a tragic but straightforward path. If such a fortress fell to an enemy, or if a fire broke out by accident, that internal wooden framework would become the wall's doom. Trapped within a stone shell, the burning timber would not have enough oxygen to blaze openly. Instead, it would smolder, creating a sustained, intense heat that built up from the inside. This is not a quick campfire. It is a slow, subterranean oven, with temperatures potentially soaring past 1,000 degrees Celsius. Certain minerals within the stone, like feldspar, can begin to melt and flow at these lower temperatures, acting as a natural glue that fuses the surrounding rubble into that familiar, glassy slag. In this view, the vitrified fort is not a mystery of creation, but a monument to a specific kind of destruction. It is the archaeological signature of a siege so complete, or a catastrophe so final, that the fortress was not just taken, but was literally consumed by its own ingenious design. The process frames vitrification as a spectacular accident, a byproduct of a society's advanced building techniques turned against them in a moment of conflict or calamity. This explanation is satisfyingly neat, elegantly linking what we know of their construction methods to the startling physical evidence we find today. It allows us to file the mystery away as solved, a dramatic footnote in the story of Iron Age warfare. But the moment we look closer, this tidy narrative begins to develop cracks as deep as the fissures in the melted stone itself. Yet the accidental fire theory, for all its elegance, cannot withstand a closer, more critical examination. The first and most fundamental challenge is one of pure physics. Could a fire of burning timber trapped inside a stone box truly generate the sustained furnace-like heat needed to melt solid rock? Experimental archaeologists have tried to recreate this exact scenario. They have built timber-laced ramparts and set them ablaze, monitoring the temperatures with modern instruments. The results are revealing. While such fires can become incredibly hot, reaching the necessary 1,100 degrees Celsius is not a simple guarantee. It requires near-perfect conditions, a strong, consistent draft to feed the flames, and an abundance of fuel. In many of these experiments, the fires burned fiercely but failed to achieve the sustained, uniform heat required to vitrify the stone core completely. The temperatures would spike and then fall, leaving behind charcoal and cracked rock, but not that signature, flowing glass. This suggests that turning an entire fortress wall into a geological kiln was far more difficult than a simple siege fire might allow. Then there is the peculiar pattern of the vitrification itself. If a fort fell to a catastrophic blaze, we would expect to see evidence of that fire everywhere. The vitrified stone should be random, chaotic, following the path of the flames, but that is not what we find at many sites. Instead, the glassy fusion is often curiously selective. It appears in specific, concentrated sections of the wall, sometimes forming thick, continuous crusts, while other parts of the same rampart show only normal signs of burning or no heat damage at all. This selective melting is hard to explain with an uncontrolled conflagration. A wildfire does not pick and choose which trees to burn. It consumes everything in its path. Furthermore, analysis of some vitrified masses reveals intricate flow patterns like the drips and runs on a candle. This indicates the stone did not just sinter or fuse where it lay. It actually became liquid enough to move, to drip downward before solidifying. That level of liquidity points to temperatures even higher than the minimum threshold, a brief but intense inferno focused on a particular spot. These inconsistencies form a troubling crack in the accidental fire hypothesis. They paint a picture that is less like the aftermath of a sack and more like the residue of a controlled event. The heat appears too focused, too intense, and too selectively applied to be merely the random result of a fortress burning down. This leads to a provocative and unavoidable question. What if the fire was not the end of the story, but the method? Could this vitrification be the evidence not of a destructive siege, but of a deliberate, sophisticated pyrotechnic technique? The idea shifts our perspective entirely. It suggests that the people who built these forts may have possessed a knowledge that went beyond simple construction. They might have understood how to harness and direct catastrophic heat, not as a weapon of war, but as a tool of transformation. This possibility pushes us beyond accidents and into the realm of ancient high-heat technology, a concept that forces us to reconsider what we believe was possible in a time we have long labeled as primitive. The leap from smelting metal to melting stone is not as vast as it might seem. To understand the possibility of deliberate vitrification, we must first step into the world of an Iron Age craftsperson. These were not people huddled around simple campfires. They were master pyrotechnicians, possessing a sophisticated and hard-won understanding of how to manipulate the very element of fire. Their most striking achievement was metallurgy. Across Europe, from simple bloomery furnaces, they routinely produced temperatures between 1,200 and 1,300 degrees Celsius to smelt iron from ore. This process required precise control over airflow, fuel, and the chemical environment within a contained space. It was a technology of transformation, turning earth into metal. Similarly, the firing of high-quality pottery and the earliest forms of glassmaking demanded similar feats of thermal engineering. These were not accidental discoveries, but the result of generations of accumulated knowledge, passed down from expert to apprentice. The crucial point is this: the intellectual and practical capacity to generate and sustain extreme heat was undeniably present in these societies. They knew how to build furnaces that could contain a small sun. So, if they could create such heat for a spearhead or a clay vessel, could that same knowledge have been adapted for a much larger, more ambitious project? Could the fortress wall itself have become the crucible? This leads us to a provocative and compelling idea. What if the timber lacing was not a fatal flaw, but a designed fuel source? Imagine a community having mastered the furnace, looking upon their newly built timber-laced rampart and seeing not just a wall, but a potential. They understood that wood burns and stone melts under the right conditions. Perhaps they conceived of a final, transformative act of fortification. Once the stone shell was complete, they might have deliberately set the internal timber lattice ablaze under controlled conditions. The goal would not be destruction, but alchemy. They would be using a directed, high-temperature fire as a kind of monumental welding torch. The intense, smoldering heat would fuse the stone rubble together, effectively fire-hardening the entire structure. In this scenario, the combustible timber is not a weakness waiting to be exploited by an enemy. It is the key ingredient in a recipe for creating something new and immensely strong. The resulting vitrified mass would be far more resistant to battering rams, climbing hooks, and the erosive power of time itself. It would turn a wall of separate stones into a single, monolithic barrier. This shifts the entire narrative from a story of tragic accident to one of potential, startling innovation. It frames the vitrified fort not as a ruined stronghold, but as a completed project, a technological triumph where the builders used the most formidable force they knew, fire, to permanently seal and strengthen their community's defenses. The silence of the stone suddenly speaks of intent, of a calculated risk that traded temporary wood for permanent, glass-bound stone. Yet, even this ingenious theory cannot fully quiet the mystery, for it raises a new and equally difficult question. If this was a controlled, deliberate technique, why is the evidence of its application so haphazard and incomplete across the many forts that used timber lacing? The search for a definitive answer pushes us to look beyond practical construction and into the realm of belief, where fire held a power far greater than any physical transformation. Yet the idea of a purely practical technology, a simple welding of stone for defense, still leaves gaps in the story. For the fire that could melt rock was not merely a tool, it was a force of profound spiritual power in the ancient world. This leads us to a perspective that shifts the entire meaning of these glass forts. What if the vitrification was never about making a fortress stronger for the living, but about performing a ceremony so powerful it would echo for millennia? In many ancient cultures, fire was the ultimate agent of transformation. It did not just destroy, it purified. It did not just consume, it consecrated. The deliberate, catastrophic burning of a significant place, especially one as central as a hill fort, was often a sacred act. It could mark a permanent closing, a ritual decommissioning of a site that had served its purpose. Perhaps a powerful chieftain had passed, and his stronghold was put to the torch so that no other could claim his seat of power. its essence ascending with the smoke. Or consider the possibility of conquest. When one community overcame another, simply occupying the enemy's fort might not have been enough. To truly pacify a territory, to break its spiritual backbone, the victors might have performed a ritual of overwhelming fire. This was not mere demolition, it was an act of symbolic magic, using the most potent force they knew to cleanse the site of its old identity and seal its history. In this light, the vitrified wall becomes something entirely different. It is not a failed rampart or a clever reinforcement. It is a permanent, gleaming monument to that ritual event. The glassy slag is the physical residue of a ceremony, a blackened scar intentionally fused into the landscape. It stands as both a warning and a memorial, a testament to an event so significant that the community chose to mark it not with a carved stone, but by altering the very fabric of the hill itself. This theory challenges our modern tendency to separate the practical from the spiritual. For these Iron Age societies, technology and belief were not separate categories. The knowledge of how to generate extreme heat was a sacred knowledge. The act of directing that heat to transform stone into glass would have been seen as wielding a divine power, an alchemy that changed the nature of reality. The vitrified fort, then, is a perfect fusion of these two worlds, a product of advanced pyrotechnic skill deployed for a deeply symbolic, cosmological purpose. It reminds us that to understand the actions of ancient people, we must sometimes look beyond engineering manuals and consider the language of myth, power, and eternity. The silent, shimmering stone may not be whispering secrets of warfare, but chanting the echoes of a long-forgotten rite. The true nature of this ancient fire is now being read in the glass itself. Modern science has given us a forensic lens to examine these melted stones, not as ruins but as evidence. Through techniques like X-ray diffraction and spectroscopic analysis, researchers can peer into the atomic structure of the vitrified material. They are asking the stone a direct question: how hot did you get? The answer is written in newly formed minerals. One key clue is a substance called cristabalite. This is a form of silica that typically only crystallizes at temperatures exceeding 1,470 degrees Celsius. Finding cristabalite locked within the glassy slag is like finding a fingerprint at a crime scene. It is definitive proof of an encounter with a truly staggering heat, far beyond what a simple wood fire might normally achieve. This data provides the hard numbers behind the mystery, confirming that the forces at work were not just hot, but were operating at the very upper limits of what ancient pyrotechnology could potentially produce. But the chemical story does not end with temperature alone. The composition of the vitrified material varies intriguingly from site to site. In some samples, scientists have detected elevated levels of elements like sodium or potassium. These act as what are called fluxes in glassmaking, substances that lower the melting point of silica, making it easier to achieve a liquid, flowing glass at a slightly lower temperature. This is a fascinating detail. It suggests the possibility that the builders did not rely solely on the natural composition of their stone. They may have intentionally added materials to the mix, perhaps plant ashes rich in these alkali elements, to engineer the vitrification process. Think of it as an ancient recipe where the right combination of stone, timber fuel, and a secret ingredient of ash could trigger the desired transformation more reliably. This moves the discussion from a question of pure chance to one of potential chemical knowledge. It implies a level of experimentation, a trial and error process where communities learned how to manipulate the properties of their own landscape to achieve a specific, spectacular result. The glass, therefore, is not just a byproduct of destruction or a symbol of ritual, it is a data storage device. It holds a record of the conditions of its own creation, the specific cocktail of heat, time, and chemistry that brought it into being. While this forensic analysis powerfully clarifies the how, giving us a detailed picture of the physical process, it simultaneously deepens the mystery of the why. Knowing they could do it with such sophistication only makes their ultimate purpose more compelling and more elusive. But reaching such impossible temperatures demanded more than just a spark. It required the perfect fuel. The timber used in the ramparts was likely green, freshly cut, and full of moisture, chosen for its structural strength. While it would burn, it would also smoke and sputter, struggling to reach the sustained, blistering heat needed to melt stone. This is where the theory of an accidental fire begins to truly falter. If the goal was vitrification, whether for defense or ritual, the builders would have needed a far more potent source of energy, and they had one right at their fingertips. They knew charcoal. This was not just burned wood, it was wood transformed through a controlled, oxygen-starved smoldering process into a carbon-rich fuel. Charcoal burns hotter, cleaner, and far more steadily than ordinary timber. It was the lifeblood of the Iron Age, the essential fuel for every smith's forge and every pottery kiln. So what if the timber lacing was not merely a framework, but a fuel reserve intentionally prepared for this higher purpose? Imagine builders not just stacking wood, but carefully packing the core of the wall with bundles of this premium processed charcoal. The wall itself becomes a massive fuel cartridge waiting for a single, decisive ignition. This changes the engineering completely. A charcoal-filled cavity, once lit and provided with a controlled draft, would not just burn, it would roar. It could create the focused, furnace-like environment that experiments with ordinary would have failed to achieve. The design of the rampart would be crucial. Gaps or channels might have been intentionally left in the stonework, not as flaws but as tires, the same air vents used in a smith's forge to stoke the flames. The entire structure could have been engineered to function as a kiln, directing airflow to superheat its core. This moves us from the idea of a tragic accident to the blueprint of a deliberate thermal machine. Yet charcoal may not have been the only option. Some researchers point to other combustible materials these communities understood. Animal fats or oils, if available in large quantities, could produce intense, sooty flames. In regions like Scotland, dense, carbon-rich peat could have been cut and dried as a slow-burning fuel. The choice would depend on local resources and knowledge. The critical point is this: the mere presence of timber in the walls is not the full answer. The real secret may have been in the specific preparation and placement of a specialized fuel, combined with a sophisticated understanding of how to engineer airflow. This suggests a level of pyrotechnic planning that goes far beyond simple construction or even ritual symbolism. It hints at a lost technical discipline, where the master wall builder was also a master firekeeper, someone who knew not just how to stack stone, but how to transform it through a carefully orchestrated inferno. The silence of the ruins now seems to whisper not of chaos, but of a recipe, a formula of stone, fuel, and air that could, for a brief and terrifying moment, summon a force of nature usually reserved for the heart of a volcano. The ultimate test of any theory lies not in a book but in fire and stone. To truly understand the mystery of the vitrified forts, modern researchers have taken a radical approach. They have tried to build their own. In a series of ambitious experiments, archaeologists like Ian Ralston in Scotland have moved from analysis to action. Their goal was straightforward: to construct a scaled-down section of a timber-laced rampart using only materials and techniques available in the Iron Age, and then to set it ablaze. The results of these fiery trials are a fascinating mix of validation and deepening mystery. In several attempts, the researchers succeeded in creating something remarkable. The internal timber did indeed burn with ferocious intensity, and in the heart of the blaze, the surrounding stone did not just blacken, it melted. Small, localized patches of true vitrification formed, complete with the characteristic bubbled, glassy slag. For the first time in millennia, humans witnessed stone flowing under a man-made fire, proving beyond doubt that the process described by the timber lace theory is physically possible. These glowing, reconstructed walls became a powerful proof of concept, showing that ancient builders with the right setup could have achieved the temperatures needed to transform their fortifications. Yet these experiments also revealed the immense difficulty of the task. While patches of glass formed, researchers struggled to achieve the extensive, uniform vitrification seen at sites like Tap O North or Peyron. Their reconstructed walls often burned in a lopsided manner, with heat surging in one area while leaving another relatively untouched. This highlighted the precise and unforgiving conditions required. Success depended on a perfect alignment of factors, the specific type of stone, which must contain the right minerals to act as a natural flux, the arrangement and dryness of the timber fuel, and most critically, the management of airflow. A fire needs oxygen to breathe, and engineering a draft through a massive stone structure without modern tools is an art in itself. The experiments suggested that achieving a complete vitrification might have required the fire to burn not just for hours, but potentially for days, a sustained, carefully tended inferno. This moves the narrative from a simple accident to a potential operation. The partial successes of modern science validate the core idea, but the repeated challenges underscore a profound respect for the ancient practitioners. They imply that the people who created these glass forts were not just lucky or tragically unlucky. They were experts. They possessed a nuanced, hands-on mastery of materials and fire dynamics, a knowledge earned through generations of observation and likely through their own, now lost, experiments. We are not looking at the residue of a single, catastrophic event, but perhaps at the signature of a perfected, though dangerous, technology. The failed attempts and partial successes of modern researchers do not diminish the ancient achievement, they elevate it. They suggest that what we find in the hills of Europe is not the result of a common practice, but the pinnacle of a rare and specialized craft, a secret of stone and flame that we are still, piece by piece, learning to read in the embers. The search for an explanation sometimes leads us down paths less traveled. Among the more speculative theories proposed for these vitrified forts is the possibility of a forgotten weapon. Could the intense, localized heat signatures be the result of a deliberate assault using a primitive but devastating incendiary agent? The idea draws a parallel to later historical weapons, like the infamous Greek fire used by the Byzantine Empire, a sticky, liquid flame that could not be extinguished with water and clung to ships and fortifications, burning with terrible ferocity. While no archaeological evidence, such as ceramic grenades or chemical residues, has been found to support the existence of such a weapon in Iron Age Europe, the thought experiment is valuable. It forces us to expand our vision of ancient conflict beyond the clash of iron and the flight of arrows. Warfare has always involved not just force, but terror, and the psychological impact of a weapon that could turn a community's stone walls into a flowing, molten nightmare would have been profound. The focused vitrification at certain points, rather than a uniform burn, could be interpreted as the result of a targeted application, as if a burning substance was hurled against specific sections of the rampart to breach or demoralize. This line of inquiry, while cautious and lacking in direct proof, serves a crucial purpose. It is a reminder of the vast gaps in our understanding. The archaeological record is, by its nature, a collection of fragments, the durable leftovers of a world built largely from perishable materials like wood, cloth, and thought. Our assumptions about the technological capabilities of prehistoric societies are built on what has survived, not on what was possible. To dismiss an idea simply because we have not yet found its physical blueprint is to potentially close a door on a whole realm of ancient innovation. Perhaps the substance was organic, a recipe of resins, oils, and fats that left no lasting chemical trace after such an inferno. Perhaps the knowledge was so potent and so dangerous that it was a closely guarded secret, lost entirely when its masters fell. Exploring this speculative territory does not mean accepting it as fact, but rather acknowledging the limits of our current narrative. It keeps the mystery alive, vibrant, and challenging, pushing us to look at the silent, glassy stone and ask not just what we see, but what incredible possibilities we might be failing to see. The true story of these forts may not lie in a single, tidy explanation, but in a complex tapestry woven from defense, ritual, accident, and perhaps a terrifying art of war now completely erased from memory. Mythology offers a different kind of evidence, written not in stone but in story. Across the Celtic and Norse worlds that overlap with these European forts, the tales are alive with fire and transformation. They speak of deities like Goibniu, the divine smith of Irish legend, whose forge produced weapons of unbreakable power and whose feast granted immortality. They tell of the dwarven craftsmen in the Norse realm of Svartalfheim, beings who worked deep within the earth, mastering metals and crafting objects of wonder and destiny. These are not stories about building walls, they are narratives about the sacred alchemy of extreme heat. In these myths, the forge is more than a workshop. It is a place of magic, where raw material is subjected to a terrifying, purifying force and emerges forever changed. This cultural memory, passed down through generations, consistently links the highest mastery of technology with the divine. It frames the ability to command such heat not as a mere craft, but as a form of power that brushes against the supernatural. So we must ask, could the vitrified forts be the real-world anchors for such myths? Imagine a community that has just witnessed or perhaps orchestrated the vitrification of their hill fort. They have seen stone flow like water, watched a rampart fuse into a single, gleaming mass under a days-long inferno. How would they explain such a spectacle to their children or to neighboring tribes? The event itself would seem miraculous, an act of power beyond ordinary human capability. It is not difficult to see how, over time, the memory of that event could weave itself into the fabric of legend. The hilltop where the stone ran like honey might become known as the place where the god of the forge tested his strength, or where heroes called down a celestial fire to seal a pact. The vitrified crust, cold and hard centuries later, would stand as permanent physical proof that the story was true. This perspective does not replace the practical or ritual theories, but rather envelops them. It suggests that for the people who built these sites, there may have been no clear line between advanced pyrotechnology and sacred ceremony. The act of generating that heat, whether for defense or for a ritual closing, would have been perceived as participating in a cosmic principle, the same transformative force wielded by their gods and heroes. The fort becomes more than a stronghold. It becomes a myth inscribed directly onto the landscape, a place where the community's history, their technological prowess, and their spiritual beliefs were literally fused together in one cataclysmic, glass-making event. The silent stone, then, speaks in the language of both engineer and poet, a testament to a time when the mastery of fire was the closest a person could come to touching the divine. The ultimate test of any defensive work is not its beauty, but its ability to withstand an assault. If we accept the possibility that vitrification was a deliberate act, we must then ask what kind of military mind would conceive of such a thing. The strategic logic, when examined, reveals a brutal and brilliant calculus. Consider the standard siege tactics of the Iron Age. Attackers might seek to scale walls with ladders, undermine them by digging tunnels, or simply batter them down with heavy rams. A standard drystone wall, even one reinforced with timber, has inherent weaknesses. Individual stones can be pried loose. The wooden framework inside can be targeted with fire to collapse a section. But a vitrified rampart presents an entirely different problem. The process of fusion turns a collection of separate components into a single, monolithic mass. There are no individual stones to pry free, no timber beams to char and weaken. The wall becomes, in essence, a giant, sloping cliff face of solid, glassy rock. The tools available to an attacker, bronze and iron picks and levers, would be laughably inadequate against such a barrier. Attempting to tunnel through it would be a task of unimaginable difficulty, the material far tougher than ordinary soil or loose rubble. From a purely physical standpoint, vitrification represents the ultimate hardening process, a one-time transformation that could turn a vulnerable stronghold into a nearly indestructible bastion. Beyond the sheer physical resistance, we must consider the psychological dimension of warfare. Imagine you are a warrior approaching a hill fort at dawn. You expect to see earthen banks or stacked stone. Instead, you are met with a sight that defies your understanding of the world. Sections of the wall gleam with a strange, dark crust catching the light in an unnatural way. The stone itself appears to have flowed and frozen, bearing the unmistakable scars of a fire so intense it could only be supernatural. The very material of the fortress has been altered by a force beyond your comprehension. The psychological impact of facing such a structure would be profound. It would signal not just strength, but a terrifying knowledge possessed by the defenders. They were not just people hiding behind a wall. They were people who could command the element of fire itself, who could reshape the bones of the earth to their will. This transforms the fort from a mere obstacle into a symbol of unassailable power. The intimidation factor alone could deter a potential attack or break the morale of a besieging force before the first arrow was loosed. Furthermore, the timing of such a transformation could be a masterstroke of defensive planning. The vitrification would not necessarily be a permanent feature from the fort's inception. A community might live for generations within a standard timber-laced enclosure. Then, upon receiving word of an approaching enemy host, a moment of supreme crisis, they could enact their final, desperate measure. Using prepared fuel stores and carefully engineered vents, they could deliberately ignite their own walls in a controlled, defensive firing. As the enemy gathered in the valley below, they would watch in horror as the fortress above them was engulfed in a deliberate inferno, not as a sign of surrender, but as an act of ultimate fortification. The walls would literally be fire-hardened in real time, transforming before the attacker's eyes. By the time the enemy reached the base of the hill, they would be facing not wood and stone, but a slick, blackened, and still radiant bastion of fused rock. This theory posits vitrification not as a static feature, but as a dynamic defensive weapon, a calculated escalation that leveraged a deep understanding of materials science for ancient military engineering. It represents a total investment in defense, sacrificing the reusable timber framework to create something permanent and terrifying. The vitrified fort, in this light, is the ultimate statement of a community's resolve, a declaration written in fire and glass that they would rather transform their home into an indestructible monument than see it fall. Yet, such a definitive, permanent solution also carries a profound finality, locking the community into a fortress that could never be easily modified or expanded, a choice that speaks volumes about the perceived threats of their time. Radiocarbon dating has given us a clock embedded in the charcoal itself. By analyzing tiny fragments of carbonized wood extracted from the heart of the vitrified stone, scientists can pinpoint when that particular piece of timber stopped growing, effectively freezing its internal atomic clock. The results from sites across Scotland and France consistently point to a broad window of time, a period stretching from roughly 800 years before the Common Era to around 200 years after. This places the phenomenon squarely within the dynamic and often turbulent European Iron Age. This was not a single, continent-wide event, but a practice that flickered into use across different regions over the course of nearly 1,000 years. Yet this chronological evidence holds a fascinating and frustrating ambiguity. When we date a piece of charcoal from within a melted wall, what exactly are we measuring? Are we capturing the moment of the wall's fiery transformation, the very instant the vitrifying blaze consumed the timber, or are we simply reading the age of the wood itself, which could have been cut decades or even centuries earlier for the fort's original construction? It is the difference between dating a historical battle and dating the tree that was later carved into a spear shaft. This uncertainty means that a date of, say, 300 BC from a vitrified fort might tell us the structure was built around that time, or it might tell us it was catastrophically altered around that time. The distinction is everything. To resolve it, researchers look for patterns and context. At certain hill forts, the radiocarbon dates from the vitrified material cluster tightly around a specific century. When this clustering aligns with other archaeological evidence from the site, like a sudden change in artifacts or signs of conflict, the case strengthens that the date marks a true turning point, a moment of deliberate or destructive fire. For instance, a date coinciding with known periods of Roman incursion or intertribal warfare can paint a vivid picture. It suggests the glassy ramparts might be the scar tissue from a specific historical wound, a community's desperate final act in the face of an overwhelming threat. This chronological detective work does more than just assign numbers to ruins. It begins to connect these silent stones to the living, breathing peoples of history. The timeframe firmly associates many vitrified forts with the Celtic cultures of mainland Europe and, in Scotland, with the enigmatic Picts. These were not anonymous builders, but distinct societies with complex art, social structures, and their own histories of conflict and innovation. Placing the vitrification within their timeline transforms it from a geological oddity into a potential historical event, a decision made by real people facing real pressures. Whether that decision was one of ritual, defense, or disaster, the emerging chronology insists we listen to these stones not as isolated mysteries, but as chapters in a much larger, still unfolding story of how ancient communities navigated a world of change, threat, and the immense power contained within a single spark. Even the weather itself may have conspired to create these glassy ruins. To fully understand the conditions that led to vitrification, we must look beyond human hands and consider the ancient sky. The climate of Iron Age Europe was not static. Paleoclimatologists, scientists who study past weather patterns, have identified periods of significant fluctuation. There is evidence to suggest that during the centuries when many of these forts were built and potentially transformed, parts of the continent experienced phases of pronounced drought. This environmental detail is not a minor footnote. It could be a critical catalyst. Imagine a timber-laced rampart standing through a series of exceptionally dry summers. The wooden beams within its core, normally protected by the stone shell, would slowly lose their natural moisture. They would become desiccated, turning from sturdy green timber into something closer to seasoned firewood. If a fire were then introduced, whether by accident or intent, this pre-dried fuel would ignite with a ferocity that green, damp wood never could. The blaze would not smolder slowly. It would leap to life, reaching peak temperatures much faster and burning with a cleaner, hotter flame. A drought-stricken landscape would provide the perfect tinderbox conditions, transforming a potential structural fire into a runaway thermal event capable of achieving the extreme heat needed to melt stone. Beyond mere dryness, the very winds that swept across these hilltop fortresses could have acted as a natural bellows. The placement of these forts was always strategic, chosen for commanding views and defensive advantage, which often meant exposed, elevated positions. Prevailing winds, channeled by the shape of the hill and the architecture of the rampart itself, might have been harnessed in a moment of fiery crisis. Gaps or intentional openings in the stonework, perhaps designed for drainage or as part of the original timber framework, could have inadvertently created a devastating draft. As a fire took hold inside the wall, these channels would funnel air directly into the heart of the blaze, feeding it oxygen with relentless efficiency. This would not be a gentle breeze but a focused jet of air, turning the core of the rampart into a literal furnace. The fort, in essence, could have become its own kiln, with the wind providing the forced air needed to push temperatures from merely hot to vitrifying. This interplay between human construction and natural force suggests that the event might have required a tragic or intentional alignment of stars. A specific day when the wind blew from just the right direction with just the right strength to create a perfect storm of heat. The final, indispensable ingredient was always the stone itself. Human ingenuity and climatic conditions could only work their magic on a material that was capable of responding. Not every type of rock can vitrify. The process requires stone with a specific chemical composition, one rich in silica and alumina. Granite, commonly used in many Scottish forts, is a prime candidate, as are certain types of sandstone. These stones contain the necessary minerals that, when heated, can melt and flow like a thick syrup before cooling into glass. Communities did not quarry and move stone from great distances. They used what was locally abundant. This creates a fascinating geographical pattern. The presence of vitrified forts may map not just to areas of conflict or cultural practice, but directly to geological outcrops that offered the right kind of rock. The builders, through generations of experience, would have intuitively understood the properties of their local stone. They knew which rocks split cleanly for building, and they may have also learned, perhaps through earlier, smaller-scale fires, which ones could fuse under extreme heat. The choice of site was therefore a multi-layered decision, blending defense, resources, and an unspoken knowledge of the land's latent potential. The hill fort was not imposed upon the landscape. It was a collaboration with it, built from materials that held a secret capability waiting for the right trigger. By reconstructing this ancient environment, we add profound depth to the mystery. We stop seeing a vitrified wall as a solitary, bizarre artifact and start to perceive it as a snapshot of a moment in time, a complex intersection of factors. It was the meeting point of human design, the timber-laced rampart with a specific material choice, the silica-rich local stone under a set of transient natural conditions, perhaps a dry season with a strong, channeled wind. This holistic view does not simplify the mystery, it enriches it. It suggests that the creation of these glass forts, whether by accident or design, was never a simple matter of lighting a match. It was an event that sat at the precarious confluence of knowledge, resource, and circumstance. The silent, fused stone before us then becomes a record of more than just fire. It is a testament to a fleeting alignment of the built and the natural worlds, an alignment so powerful it literally changed the substance of the earth. The story of vitrified stone is not confined to the windswept hill forts of Europe. To truly grasp what makes them unique, we must glance at other corners of the ancient world where fire also met rock. In the long, grassy mounds of Neolithic Europe known as long barrows, which served as communal resting places, archaeologists have sometimes discovered patches of stone that bear the marks of intense heat. These are not melted ramparts, but rather sections of the internal chambers or surrounding curbs that appear to have been deliberately fired, possibly as part of a ceremonial practice to seal or sanctify the space. The heat was applied, but the goal was not structural fusion on a massive scale. Across the Atlantic, in the Americas, we find another fascinating parallel. At sites like the Adams site in Tennessee, part of the ancient Mississippian culture, earthen platform mounds were sometimes capped with a layer of clay that was intentionally baked into a hard, brick-like crust using controlled fires. This process, known as thermal alteration, strengthened the mound's surface. Yet again, the material transformed was earth, not solid stone, and the temperatures achieved were for hardening, not for creating flowing glass. These scattered examples reveal a crucial truth. Ancient peoples in many times and places understood that fire could change the earth. They used it ritually to consecrate and practically to stabilize. But what we see in the vitrified forts of Iron Age Europe is something categorically different in both degree and intent. It is not the surface baking of clay or the localized scorching of tombstones. It is the systematic, wholesale transformation of entire defensive walls, tons of silica-rich rock, into a monolithic, glass-welded barrier. This scale and consistency set the hill forts apart. The comparative view acts like a filter, helping to isolate the extraordinary core of our mystery. It suggests that while the concept of applying transformative heat was a widespread human discovery, the specific recipe that produced vitrified ramparts, the precise mix of timber-laced architecture, suitable geology, and either deliberate pyrotechnic skill or a perfect storm of destructive conditions represents a peak. This peak was reached in a specific time and place, the Celtic world of the first millennium before the Common Era. It stands as a localized technological tradition, or perhaps a repeated historical trauma, that turned a simple understanding of fire into something that could literally reshape the landscape of power. Yet the very extremity of this phenomenon makes it a magnet for modern myth. In the shadowy corners of pseudo-archaeology, vitrified forts have been recast as evidence for impossible histories. Wild narratives suggest they are the scorched battlefields of an ancient atomic war, or the target points of alien laser weapons from a forgotten interstellar conflict. These stories are gripping science fiction, a thrilling reimagining of the past where every mystery must have a spectacular, otherworldly cause. They capture the imagination because they speak to a deep human desire for grand, lost epochs and hidden truths. But as compelling as these tales can be, they perform a subtle disservice to the very people whose achievements we are trying to understand. By attributing the vitrified stone to atomics or aliens, these theories implicitly dismiss the ingenuity of Iron Age societies. They suggest that such a transformation was so far beyond human capability that only an outside, superior force could be responsible. This robs our ancestors of their own agency and intellect. It turns a testament to human innovation into a monument to human inadequacy. The core of these fringe claims almost always involves a selective reading of the evidence. They focus on the startling end result, the melted stone, while ignoring the intricate trail of clues that lead back to the earthly, the possible, and the human. They disregard the charcoal in the walls, the patterns of timber lacing, the local geology, and the rich archaeological context of pottery, tools, and settlement patterns that firmly anchor these sites in their own time. A theory of ancient lasers offers no explanation for why this glass appears only in certain types of defensive structures built during a specific period, using a very specific construction technique. It cannot account for the failed experiments, the partially vitrified walls that show us a process of trial and error. Addressing these speculative stories is not about giving them a platform, but about drawing a crucial distinction. It is the difference between mystery and mystification. A true mystery invites investigation, careful gathering of evidence, and a humble acknowledgement of what we do not yet know. Mystification, by contrast, offers a prepackaged, sensational answer that short-circuits curiosity and replaces genuine inquiry with a satisfying fantasy. The real, profound wonder of the vitrified forts lies in the demonstrable, material fact that people 2,500 years ago, using the wood, stone, and fire of their world, orchestrated conditions so severe they altered the fundamental state of matter. They took a hill, built upon it with intelligence, and then, whether by design or disaster, summoned a force that turned their strongest ramparts into a new, gleaming substance. That reality, achieved within the constraints of their time and knowledge, is a far more astonishing and human story than any tale of lost superweapons. It connects us to them not through fantasy, but through a shared capacity for problem-solving, for harnessing the elements, and for leaving a mark upon the world so permanent it still confounds and inspires us today. But the very forces that created these glass forts now threaten to erase them. The vitrified stone that withstood ancient infernos faces a slow, modern siege from the elements it was exposed to for centuries. Rain, especially the slightly acidic rain common in industrialized regions, does not simply run off the glassy surface. Over decades, it can slowly dissolve the mineral bonds, causing the once solid crust to flake and crumble. Freeze-thaw cycles are another relentless enemy. Water seeps into microscopic cracks in the stone, then expands as it freezes, acting like countless tiny wedges that pry the vitrified mass apart from within. Even life itself becomes a destructive force. Hardy lichens and mosses colonize the rough surface, their root-like structures digging into the fragile glass. Larger plants and shrubs can take root in the soil that accumulates in crevices, their roots exerting immense pressure as they grow, further fracturing the ancient masonry. This is the paradox of preservation, the same exposure that makes these hill forts so striking and accessible also subjects them to a gradual, irreversible decay. The stone that was fused in a single, catastrophic event is now being undone by the cumulative drip of water and the silent push of a root. Beyond natural weathering, a more direct human impact compounds the problem. The growing fascination with these sites draws visitors, a testament to their power to captivate us. But footfall on unprotected slopes leads to soil erosion, destabilizing the ground around the ramparts. More troubling is the temptation to take a piece of the mystery home. Unauthorized sampling, where individuals chip off a fragment of the vitrified stone as a souvenir, inflicts direct and irreparable damage. Each small piece removed is a unique data point lost forever, a piece of the story stolen. This places organizations like Historic Environment Scotland in a difficult position. At sites like the formidable Tap O' North, they actively monitor the condition of the vitrified walls, using photography and detailed surveys to track changes over time. Their work is a delicate balancing act. They must manage public access, constructing paths and signage to guide visitors in a way that minimizes harm, while simultaneously restricting contact with the most fragile archaeological features. The goal is not to hide these wonders away, but to safeguard them. These vitrified ramparts are a non-renewable resource. Unlike a historic building that can be repaired with new stone, the glassy fusion is a one-time event, a snapshot of a specific ancient process. Once a section is eroded or removed, the information it contained about temperature, technique, and timing is gone for good. Preserving them is not merely about protecting old rocks, it is about protecting the physical evidence of a profound human achievement. The silent, glass-clad hill must continue to speak, and its survival now depends on our willingness to listen with care and walk with a lighter step. The silent stones hold their secrets in a language of chemistry and physics. To translate it, we need more than a trowel and a notebook. We need a laboratory. This is where the mystery of the vitrified forts transforms, moving from the lonely hilltop into a vibrant, collaborative space where the past meets the cutting edge of modern science. Today, solving this ancient riddle is no longer the sole domain of the archaeologist. It is a team effort, a conversation between disciplines that once rarely spoke. Picture a geologist examining a thin slice of vitrified rock under a polarizing microscope, identifying the crystalline fingerprints of extreme heat. A chemist uses a portable X-ray fluorescence analyzer on site, instantly reading the elemental signature of the glass to see if fluxes were added. An engineer runs complex thermal models on a computer, simulating how air would flow through a timber-laced wall during a fire. This fusion of fields is revolutionizing our approach. It treats the vitrified fort not merely as a historical artifact to be catalogued, but as a complex materials science problem waiting to be reverse engineered. The questions become more precise. Not just was it hot, but exactly how did the heat move through the structure? Where were the hotspots? How long did the critical temperature need to be maintained? Tools like three-dimensional laser scanning allow researchers to create millimeter-perfect digital models of an entire vitrified rampart. These are not just pretty pictures, they are data-rich maps. By analyzing the precise contours and thickness of the glassy crust, scientists can begin to model the fire's behavior, seeing if the vitrification is thicker in areas that would have had better airflow, or concentrated in corners where heat might have built up. This digital reconstruction lets them test scenarios without ever lifting a stone. They can virtually add more fuel, change the wind direction, or alter the wall's porosity, watching how the theoretical flames spread and where the temperatures peak. This interdisciplinary dialogue does something profound. It builds bridges of understanding between the ancient mind and the modern one. The archaeologist provides the context, the when and the who, the story of the people who built the fort. The materials scientist provides the how, the rigorous analysis of the process itself. Together, they can ask, did these builders understand the thermal properties of their local stone as intimately as they understood its strength? Could they have predicted, even roughly, the outcome of such a conflagration? This collaborative lens opens entirely new avenues for understanding the sequence of events locked in the stone. It allows us to move beyond speculation toward evidence-based reconstruction, piecing together that final, fiery chapter not from guesswork, but from the immutable laws of physics and chemistry that the ancient builders themselves had to navigate. The future of this mystery, and indeed of archaeology itself, lies in this powerful synthesis where every scorched wall becomes a classroom, teaching us about the enduring human quest to master the elements. The glass fused into these hilltops is more than a technical marvel. It is a mirror reflecting the society that created it. To grasp its full meaning, we must look past the chemistry of the stone and into the social world of the Iron Age. The very existence of a timber-laced fort reveals a community of remarkable organization. Constructing such a massive, engineered rampart was not a weekend project for a few families. It demanded a coordinated labor force, hundreds of people working together to quarry stone, fell and shape enormous timbers, and execute a complex architectural plan. This points to a society with clear leadership, the ability to mobilize resources, and a shared commitment to a common goal. The fort was not just a military installation, it was the beating heart of a community. Within its walls, people lived, worked, traded, and governed. It was a symbol of collective identity and a seat of authority for a chieftain or a ruling council. The sophistication of the design, especially the precise timber lacing, tells us this society also nurtured specialists. Master woodworkers who understood joinery and structural stress worked alongside stonemasons and perhaps even early engineers who could visualize how these materials would interact over time. Then there is the potential mastery of fire. If the vitrification was deliberate, it implies an even higher level of specialized knowledge, a pyrotechnical craft so advanced it bordered on the sacred. This suggests a social structure that valued and supported such experts, individuals who held the dangerous and awe-inspiring secrets of transformation. So what would drive such a society to risk everything on a single, fiery act? The motivations are deeply human. For defense, it represents an ultimate expression of communal will, a willingness to sacrifice the reusable timber framework to create a permanent, terrifying barrier against an existential threat. It is the action of a people who valued long-term security over short-term convenience. If the act was ritual, it speaks to a profound spiritual worldview. Decommissioning a chief's fort with sacred fire or cleansing a conquered site through an alchemical blaze shows a belief that places held power, and that power needed to be managed through ceremonies of cosmic significance. And if the act was one of display, it was the most dramatic statement of power imaginable. A chieftain who could command the very stones of his stronghold to flow and fuse was demonstrating a control over nature that reinforced his authority and deterred rivals. The event itself, whether a planned ceremony or a catastrophic siege, would have been seared into the memory of the tribe. It would become a foundational story, a before and after marker in their history. The transformed hill, gleaming under the sun, would stand for generations as a permanent landmark in their oral tradition, a constant reminder of a time when their ancestors faced the fire and changed their world. The vitrified fort, therefore, is not an isolated puzzle. It is a cultural document. In its silent, glassy lines, we read the ambitions, fears, and incredible capabilities of a people who understood that to build a community, you must first master the elements, and sometimes you must be willing to transform your greatest creation to ensure its legacy endures. Centuries of study have not silenced the debate, they have only refined the questions. We are left staring at the same glassy ramparts, asking if we are looking at a forgotten technology, the residue of a sacred rite, or simply the repeated signature of a specific kind of disaster. The core puzzle of intentionality remains stubbornly unresolved. Can we ever find definitive proof that the people who built these forts meant for them to turn to glass? The challenge is that the same physical evidence, the charcoal and the melted stone, can be interpreted in multiple ways. A layer of charcoal could be the planned fuel for a transformative fire, or it could be the tragic remains of a roof that collapsed during an attack. Without a written manual or an eyewitness account from the Iron Age, we are left reading clues in a language where every word has several possible meanings. This ambiguity is precisely what keeps the investigation alive and contentious. It forces every new researcher to confront their own assumptions about the capabilities and motivations of ancient societies. Are we projecting modern ideas of efficiency and engineering onto people for whom spiritual and symbolic actions held equal or greater weight? The debate itself becomes a reflection of how we choose to see the past. Geography adds another layer of mystery. Why do we find these vitrified structures scattered across Scotland and parts of France, but not, for instance, in the equally fortified hill forts of England or Germany? This patchy distribution suggests the phenomenon was not a universal stage of Iron Age development. It was something specific, a cultural practice or a localized response that emerged under particular pressures. Perhaps it required a confluence of factors found only in certain regions, the right type of stone, a tradition of timber-laced architecture, and a period of intense, focused conflict or social change. The map of vitrified forts is not random. It is a cryptic diagram pointing to a story we have not yet fully pieced together. A story of interconnected communities who shared a dangerous and spectacular secret, or who suffered through a similar kind of fiery upheaval. This is why the research continues with renewed focus. Archaeologists are no longer satisfied with dating a site to a broad century. They now pursue finer-grained chronologies, using advanced radiocarbon techniques on multiple samples from a single wall. The goal is to see if the charcoal from the vitrified core dates to the exact same short period as charcoal from the fort's living floors. If they match precisely, it strengthens the case for a single, catastrophic event. If the vitrification charcoal is significantly younger, it could indicate a deliberate renovation long after the fort was built. In the laboratory, material scientists subject tiny fragments of the glass to increasingly sensitive analysis. They search for chemical gradients, minute variations in composition from the center of a vitrified mass to its edge, which could reveal how the heat spread and how long it was applied. They look for traces of added substances with a forensic eye, hoping to find the unmistakable fingerprint of a prepared accelerant or flux that would scream of human preparation. Perhaps the most dynamic frontier is experimental archaeology. Each new reconstruction is more sophisticated than the last, incorporating lessons from past attempts. Researchers now build larger wall segments, using sensors embedded throughout to create a real-time thermal map of the fire. They experiment with different fuel arrangements, mixing green timber with dry or packing the core with peat and charcoal. They engineer subtle air channels, testing how the design of the rampart itself could have acted as a furnace. These are not just bonfires, they are controlled scientific inquiries that treat the ancient wall as a hypothesis to be tested. Every season of excavation, every result from a mass spectrometer, every new day to point from an experimental burn has the potential to tip the delicate scales of interpretation. A discovery of a vitrified fort with clear, internal channels designed solely for airflow could revolutionize the field. Conversely, finding a site where the vitrification perfectly overlaps with layers of weapons and siege damage might finally confirm the tragic accident theory. The enduring power of this mystery lies in its refusal to be claimed by any single discipline. It sits productively at a crossroads where the archaeologist, the geologist, the chemist, and the engineer must all sit at the same table. It resists a simple, elegant answer because the past itself is rarely simple. The vitrified forts compel us to keep looking, to keep questioning, and to hold space for the possibility that ancient people achieved things that still, even with all our technology, give us pause. They stand as permanent challenges not just to our understanding of history, but to our imagination of what is possible when human ingenuity meets the elemental force of fire. These glass-clad ruins are not anomalies, they are provocations. They challenge the quiet assumption that technological progress in the ancient world was a slow, linear crawl from simple to complex. The existence of vitrified forts suggests something far more dynamic, a culture of bold experimentation where known techniques were pushed into uncharted territory. This was not innovation for convenience, it was a high-stakes gamble with the most fundamental elements of shelter and security. Think of it this way, mastering the furnace to smelt iron was a revolutionary act, but it followed a recognizable logic, the transformation of ore into a usable, durable material. Applying that same pyrotechnic knowledge to an entire fortress wall, however, operates on a different plane of ambition. It moves the workshop from the edge of the settlement to its very heart, scaling a craft process up to the level of civic architecture. The builders were not just making an object, they were attempting to alter the immutable nature of a place, to turn a collection of stones into a single, fused entity. This reveals an innovative spirit that was both pragmatic and profoundly audacious. It demonstrates a willingness to ask, what happens if we take the principle of the forge and make the wall itself the crucible? The answer, written in shimmering slag, shows they were willing to find out regardless of the immense risk. Such a venture implies a society that supported its specialists, giving them the resources and the social permission to attempt something that could easily have resulted in catastrophic failure. A failed smelting yields a lump of useless slag, but a failed vitrification attempt on a live fort could have meant the loss of the community's primary defense, or worse, a runaway fire that consumed everything within. The fact that we find these sites at all, that the process was achieved even partially, speaks to a culture that valued exploratory thinking and technical daring. It reframes our view of prehistoric Europe from a place of static tradition to one of active, sometimes radical, material science. The engineers and smiths of this era were not merely replicating the knowledge of their fathers, they were expanding it, testing the boundaries of their world by seeing how far they could push fire, stone, and human ingenuity. Their full repertoire of high-heat applications was likely far richer than the fragments that survive. What other large-scale transformations, now lost to time because they left no such permanent scar, might they have attempted? The vitrified fort stands as a permanent reminder that the past was not a simpler time, but a different one, filled with its own complex questions and astonishing glass-hard answers. The world of the vitrified fort was not an isolated bubble in time. Its fiery glow illuminated a continent on the cusp of profound change. While these hilltop communities were mastering the alchemy of stone, another civilization far to the south was forging an empire of a different kind. The rise of Rome was reshaping the Mediterranean world, its legions and its laws beginning a slow, inexorable push northward. At the same time, the Celtic tribes of temperate Europe were in motion, their intricate art and warrior societies spreading and shifting across the landscape. The vitrified forts stand precisely at this historical crossroads, a product of the dynamic, late Iron Age societies that thrived for centuries before their eventual, fateful encounters with the Roman war machine. This context is crucial, for it frames these structures not as primitive relics, but as sophisticated statements from a world with its own rules and its own vision of power. These forts represent a distinctly non-Roman expression of community and authority. The Roman ideal of power was linear, centralized, and monumental, expressed through straight roads, planned cities, and standardized legionary forts. It was an empire built on administration and assimilation. The power expressed in a vitrified hill fort, by contrast, was local, anchored, and symbolic. It was not about projecting control over a vast territory from a distant capital, but about asserting an unbreakable bond between a people and their specific place in the world. The choice to fuse a fortress to the very hill it stood upon is the ultimate declaration of this kind of rooted power. It says, "We are here, and this place is us, transformed and made permanent by our will and our knowledge." This was a technology of belonging, a way to make the landscape itself an ally and a testament to the community's identity. When we finally place these glass-clad strongholds within the broader tapestry of European history, they force us to expand our vision. For too long, the narrative of this era has been viewed through a Mediterranean lens, with the literate civilizations of Greece and Rome acting as the sole protagonists of progress. The vitrified forts challenge that narrow perspective. They are a stunning testament to a parallel tradition of innovation that flourished in the forests and highlands of the north. The people who built them were not waiting for civilization to arrive from the south. They were actively building their own, solving complex problems of engineering, defense, and social cohesion with the materials and the genius of their own environment. Their mastery of pyrotechnology was not a crude precursor to Roman engineering. It was a different branch on the same human tree of ingenuity. Understanding these forts enriches our picture of a diverse and complex prehistoric world. Europe was not a blank space marked barbarian waiting for Roman conquest. It was a vibrant mosaic of cultures, each with its own social structures, artistic traditions, and technological specialties. The vitrified hill fort is one brilliant tile in that mosaic. It reminds us that history is never a single, unified story marching toward a predetermined destination. It is a collection of countless stories of different peoples confronting universal challenges: how to protect a community, how to express belief, how to leave a mark, and arriving at wildly different, often breathtakingly creative solutions. The silent, shimmering ramparts on a Scottish hill or a French headland are not just puzzles for archaeologists. They are powerful emissaries from a lost world, asking us to remember that the human past is far richer, far more inventive, and far more mysterious than any single narrative could ever contain. The glass-strewn ramparts of these ancient hills do not offer us a final verdict. They offer something more profound, a shimmering testament to the vast and fertile gaps in our understanding of the past. Our journey has taken us from the windswept coasts of Scotland to the laboratories of modern material scientists, through theories of catastrophic accident, sacred ritual, and daring defensive innovation. We have seen how a single, silent phenomenon can refract into a spectrum of possible truths, each colored by the lens through which we view our ancestors. The definitive answer, the one clear reason why these stones were fused, remains as elusive as the last ember of that ancient fire. Yet in this very elusiveness lies the real power of the mystery. The relentless pursuit of an explanation, the centuries of debate and experimentation, have illuminated not just a forgotten process, but the dynamic, inventive spirit of Iron Age societies themselves. We are forced to move beyond seeing them as primitive tribes and instead recognize them as pragmatic experimenters, as communities who possessed a sophisticated material wisdom born of deep intimacy with their environment. They understood the character of their local stone, the behavior of different fuels, and the potential of controlled fire, not from textbooks, but from generations of hands-on trial and observation. The vitrified fort is the ultimate expression of this wisdom, a place where technology, culture, and the raw forces of nature converged in a single, spectacular moment. These ruins stand as a permanent challenge to our modern arrogance, a reminder that history is rarely a linear march of progress, but a tapestry of diverse solutions to universal human challenges. Perhaps then, the greatest lesson from these silent, glass-clad sentinels is not about finding the one right answer. It is about learning to ask better, more humble questions. It is about listening to what the stones can tell us of heat and time, while remaining open to the whispers of ritual, the echoes of conflict, and the brilliant, forgotten sparks of ancient innovation. The mystery endures not as a failure of archaeology, but as its greatest success, an invitation to keep looking, wondering, and respecting the profound ingenuity etched into the very bones of the land. So the next time you walk a windswept hill or see an outcrop of ancient stone, pause for a moment, look closer. The landscape beneath our feet is not a static backdrop. It is a living archive holding stories of innovation, conflict, and belief from worlds long gone. The mystery of the vitrified forts is one such story, a testament to the incredible things ancient people achieved with the materials they had. We have walked through the theories together, from accidental infernos to sacred ceremonies and daring defensive acts. Now we turn the question to you. When you look at the evidence, where does your curiosity lead? Do you see the glassy ramparts as the solemn residue of a ritual farewell, the scorched aftermath of a desperate last stand, or the bold signature of a forgotten high-heat technology? The conversation does not end here. Share your perspective in the comments below. Let us know which explanation resonates most with you and why. Your thoughts become part of the ongoing investigation, a modern community puzzling over an ancient enigma. If exploring these deep corridors of the past captivated you, there are countless more mysteries waiting. To join the next journey into archaeology's greatest puzzles, be sure to subscribe and tap the notification bell. Together, we can keep unraveling the secrets woven into the very fabric of our world, one story, one stone, one spark of curiosity at a time. Thank you for venturing to that fiery frontier where history meets mystery and where stone, against all expectation, learned how to flow.